Hello everyone. Welcome to the lecture series of Computer Networks. I am Harsh Khattar, working as Assistant Professor in Department of Computer Science at KIET Group of Institutions, Ghaziabad. In last class, we have seen about the methods of data transmission at data link layer. Basically, in MAC layer, we have these protocols for the smooth transmission of data. But there are few issues like collision. So, how we will resolve the collision? We have multiple methods. We tried from our side for the collision avoidance. Today, our focus is on the flow control and the error control method while transmitting the data. First thing to understand is what exactly flow control is. If I am sending the data and at the receiver end speed is not appropriate, what will happen? I am continuously sending the data and receiver is not receiving it. So, we have seen when we start the motor and the flow of water is more and the capacity is less, what will happen? The water overflows. So, in this case we have the data, and if the speed of sending the data is more and the receiving of data is less, in this case we have seen that the data overflows or might be the data loss, or if there is a condition of collision or loss of data or damaged packet or frame. So, in this case what we will do? So, in case of failure we have the error, and if there is a speed variation, then we have a flow control. So, here the role of data link layer is also the control of flow and the error while transmission of data. These are the two most important responsibilities and the functionalities of data link layer. As it is mentioned here, in flow control, what we are expecting? We are expecting if one frame is received at the receiver end, then receiver will send the acknowledgement. Once I receive the acknowledgement of frame 1, I will send the frame 2. This is flow control, so that I can understand the speed of receiving at receiver end. Is the speed of receiver mapped with the speed of sender, means my speed? So, this is about the flow control. Error control, if there is any sort of damaged frame or the duplicate frame, the multiple frames are received at the receiver end, what will happen? If a particular frame is not received as it is sent by me, then what will happen? So, there must be some automated mechanism, and this is known as the error control. So, in this lecture our focus is on the flow control and the error control of data transmission. Generally, we talk about the two types of schemes. One, if the network, the channel is noiseless, there is no such noise. What is the meaning of noise? There is no any type of distortion. If there is no such distortion, there is no type of collision, there is no constraint of damaged packet or the packet loss, then we generally follow these simplest algorithms. These two both are the simplest ones, but the name is, this one is simplest and this is stop and wait. Both comes under the noiseless channel mechanism. And if we talk about the noisy channel, means if I am talking about the wireless medium, in this case, or practically we can't say my channel is noiseless, not 100% noiseless, might be in one channel, in one transmission medium we say yes there is 0.1% noise or might be 0.001% noise, but practically noise is present. So, for practical things, practical scenarios, we have these three methods for the noisy channel. So, in this class we will discuss about these 5 methods. Number 1, what is the noisy channel and what is noiseless channel? As I said, if the channel we have don't have any frame to loss, duplicate or corrupted or damaged. So, in such scenarios we assume my channel is noise free or noiseless channel. So, as I discussed in the previous slide, if we have a noiseless channel, then we have two categories under this. Category number 1 says Yes, simplest approach. If there is a sender is there, yes, frames are ready, it is getting the data link is there, then this is a physical layer. In the this is OSI layered structure. So, in this OSI model, you will see network layer, data link, physical layer, and here the bit stream starts transmitting. So, here the data frames are moving from sender side to the receiver side, and receiver is receiving the packet. This is the simplest one, the positive approach. Whatever I am sending, receiver is receiving it. Okay? There is no issue in this. This is the simplest one. So, if I represent this in form of the sequence diagram, then you will see here, this is a sender A, one frame is ready, A sends first frame. This is a time axis. So, first frame is ready, it is arrived at the receiver end. After few minutes or after a specific time amount of time, this is frame 1, frame 2 arrived, frame 3 arrived. This is the simplest approach. Now, come to the constraints. What will happen if frame 2 is not reached as the receiver end? Because there is no such acknowledgement. So, here we are talking about the optimistic approach, a positive approach. Whatever I am sending, my friend is receiving it. Not that particular one that I have text my a message that I am reaching at 5 PM at your home and my friend is not received any message from my side, because I do not get any acknowledgement. So, I reach to my friend's house. So, this is not the approach, because my packet is lost, damaged. So, this is an example of noisy channel, but here the constraint is the channel is noise free. So, I am assuming whatever I am sending, receiver is receiving it with the positive note. So, this is the simplest approach. So, here what is the objective for this? Means the flow control is okay, whatever I am sending, receiver is receiving, there is no error. Next approach, where I am waiting for, yes, receiver is receiving it or not receiving it, might be there is issue at the receiver end. How I come to know about this? This is a second method which says stop and wait protocol. Stop and wait means, yes, am I audible? If from your side you are saying yes, you are audible, this is acknowledgement. If again and again I am saying yes, I am saying something, I am saying second line, third line, fourth line, yes, I am sending the packet, but might be from my side my mic is off and you are not receiving anything, but I am assuming yes, you are receiving all the things, you are receiving whole my voice and audio. So, this is the optimistic approach which I am assuming in the first case, but now I need acknowledgement from your side. Whatever I am saying, am I audible? You are saying yes or no, not clearly audible, means this is some sort of acknowledgement. So, here if I receive yes from your side, yes sir, you are audible, only then I will say now I am starting my today's lecture. So, this is the approach under the stop and wait protocol, where the focus is on the feedback. So, here the sender waits for the feedback from the receiver side. Once sender received the acknowledgement, then sender will send the second frame, otherwise sender will wait for a time. Okay? So, this is the second approach. This is again in the noise free channel, noise less channel that I am waiting for, because I am talking about the flow control. I want to check that if I am sending the packet, are you receiving it in a correct manner or not. So, this is the algorithm. So, here if the frame 1 transmitted by the sender and received at the receiver end, then receiver will send the acknowledgement frame. Once this acknowledgement will received at the sender end, then sender will send the frame 2 like this. So, this is the one-to-one communication, one frame received, one acknowledgement received, another frame received, another acknowledgement received, like this. So, the sequence diagram for this is this one. It is very easy to understand, like sender is sending the frame 1, yes, at receiver end, receiver receives it, then send the acknowledgement of frame 1, then frame 2, then acknowledgement of frame 2, like this. So, one on one, if I am saying something, you are replying. So, this is the complete interactive session. So this is what stop and wait protocol says. So these are the two major ones under the noiseless channel, simplest and stop and wait. Now come to the practical scenario. What is this practical scenario? Practically we have noisy channel in which frames can be lost, duplicated, corrupted or damaged. So practically we can't say it is a noise free. If you are not receiving up my voice, might be there is some sort of issue, there is some sort of distortion in the signal, might be from my side or your side. So what is the solution for this? So we have three main protocols under this, and for the university exam these three are very important. Stop and wait with automatic repeat request. If after a specific time I am not receiving the acknowledgement, I will ask again. Okay, so this is automatic repeat request. Next, go back in, and third one is selective repeat. So in university exam might be you will see any question on the difference or the working of 5 marks or 10 marks. So one by one let's have a look to this. First one, stop and wait but automatic repeat request. Previously we have already studied about this stop and wait. Stop and wait says if I am sending something, you are replying me, yes I have received. Again I am sending something, you are saying yes I have received. If I am saying yes, am I audible, but no response from your side, I will wait for a specific time. Then I will ask again, yes am I audible. If again I am not receiving any response, what I will do? I will send it again. So there is a chance of retransmitting of packet, but this is in an automated manner. So a particular algorithm waits for a specific time and then send the data. So if I talk about the working of stop and wait, ARR, so this is known as ARR, automatic repeat request. So in this case the error part is removed in such a manner or overcome in such a manner. So here in stop and wait method we are talking about the acknowledgement number. Once I am sending the data, I am receiving the acknowledgement. So what is a flow chart for this? How you can represent it in the sequence diagram? Say this. With the help of this diagram, you will understand the working of stop and wait automatic repeat request method. So what we are trying to do here, there is a entity sender who is sending the packet and receiver who is receiving it. First I have sent frame 0. As per the policy, I am receiving the acknowledgement. Once I have received the acknowledgement, here you will see the numbers 0 and 1. 0 says yes frame number 0 is sent, and now acknowledgement receives, I have received the frame 0, so I am expecting the 1. So in this manner you will see 1 plus acknowledgement number. So here this is a frame 1, acknowledgement 1. Then another frame, sender is assuming I have sent the frame 1, but receiver has not received it. No issue. Sender resend the frame 1. Why? Because this particular time is the time period to check for the acknowledgement. I am waiting for your acknowledgement that am I audible. If nobody responses, I will ask again. So this is the frame 1. Once I will get the response, yes this is acknowledgement 0, acknowledgement 0 means currently this is a recent packet what I have received. So this is the acknowledgement 1. Then again they are sending the frame 0, yes the next one was the 0 1. Then yes the acknowledgement was lost. So if the acknowledgement is lost, then again same packet will be sent. Same, that there is a time, waiting time. Between this, if no acknowledgement is received, the packet will be sent again. So here this is one-on-one collaboration. If sender is sending something, sender is expecting the acknowledgement. Otherwise, after a specific time, the timeout will be there and sender will send the same packet again. Again waiting for the acknowledgement of either it is an acknowledgement of packet 1 or packet 0 or frame 1 or frame 0 or frame 10. So whatever the number is there, based on the number the acknowledgement plus 1 is sent. Similarly, the frame will be resent and then yes, I have received the frame 0, so now send the another frame. So this is how the data is transferred using the stop and wait automated repeat request. Okay? So, this is the first scheme. Here you will also see the same diagram in this book, all the diagrams are from the book only. Now, what is the next approach? Next approach says, if I am waiting for a long time, every time I am asking, my counter is 5 minutes and I am receiving the response after 4 minutes, or I am not receiving. So, after 5 minutes I am sending a packet again. So, why not I can do one thing, I can collectively send you the packets 1, 2, 3, 4 and collectively you can send the acknowledgements, like I have received 1, received 2, received 3. If the acknowledgement of 4 is not received, I will send it again. So, in this manner I have maintained a contention window, like I am sending 4 frames in a one go. So, how it is one go? I have created a window. Suppose, take this scenario, I have seen, just focus on this, I have mentioned here that my window size is say this and 7 frames are allotted. I have sent frame 1 means frame 0, then frame 1, frame 2, and by the time I have not received any acknowledgement, no issue, because my window size is of 7 frames. So, I can send 7 frames continuously without receiving the acknowledgement. But after this, I need the acknowledgement. If I have received the acknowledgement of 0, only 0, then what I will do? I will shift my window to this, then I will send one more packet or frame. If I received the acknowledgement of 1, 2, 3, now what I will do? 1, 2, 3, 1, 2, 3, 4. Now my window is shifted towards this. Now I will send frame 8, 9, 10. Suppose I received, now I received the acknowledgement of 5, 6, 7, but not received the acknowledgement of 4. What will happen? If I am not receiving the acknowledgement of 4, I will wait till the acknowledgement of 4 reaches. Otherwise, I can't increase the size of window. I need to send all the packets again, because I am assuming is if 4 is not received yet, I will not accept the acknowledgement of 5, 6, 7. Okay? So, this is some sort of better approach than the stop and wait, where it was 1 to 1 check. If one frame is sent, one acknowledgement received. Here I can at least send the multiple frames and wait for the acknowledgement, but in sequence. How we can do this task? See this. This is again a sequence diagram between the sender and receiver. We are assuming this is a sender, receiver. This is my contention window. Window means I have asked for the multiple frames inside a single time duration. So, I am sending first frame 0, then I am sending frame 1, frame 2, 3, because this is my window size. So, window size is up 7 frames, this 0 to 6. So, in this case, one by one, when I am sending the frames, and here at particular time when the timeout is there, because timeout is there with all the frames. Okay, we are not removing the timeout concept, we are just adding one functionality that we can send multiple packets without expecting acknowledgement for a specific time only. Means if my time is 1 minute, so previously I am sending packet 1, waits for 1 minute for the acknowledgement, otherwise sending packet 1 again. Now still the time is 1 minute, but I can send frame 1, frame 2, frame 3, frame 4. Now 1 minute is over. Have I received this particular acknowledgement of frame 1? No. I will send the frame 1, frame 2, frame 3, frame 4 again, because I am expecting if the acknowledgement of 1 is not received, then all the subsequent frames are also not received. So, here sometimes retransmission is more. If a packet is already received or frame is already received, still I am sending it. So, focus on the diagram first. Here the acknowledgement is not received, then the retransmission of frame 1 is there, because acknowledgement of this is received, then the window size will increase, then frame 1 timeout, it will resend again, frame 2, frame 3. So, all the frames will be received, then acknowledgement 2, 3, 4, and in the same manner the window will increase. So, this is how the this go back n. So, what is the meaning of go back n? Means n number of frames are repeatedly transmitted. Okay, repeatedly we are retransmitting these n frames, like acknowledgement of 1 is not received, but in the window till now 1, 2, 3. So, all 3 frames will be retransmitted, resend. So, that is why the name is go back n. So, n frames are going back to the receiver. Another important one is the selective repeat. Now, what was the issue in previous one? If the window size is 4 and we are saying 3 packets are received, but the prior one was not received. So, in this case we are sending all 4 packets again, all 4 frames again. So, is it a good practice? Answer is no, because we are expecting if one is not received at the receiver end, might be 2, 3, 4 are received. So, why we are sending 1, 2, 3, 4 all 4 frames to the user? So, what is the solution for this? Selective repeat. Selective repeat says only that particular frame will be sent which is not acknowledged by the receiver. If out of 1, 2, 3, 4, if the acknowledgement of 1 is not received, then why I am transmitting the 2, 3, 4? In this case, I will only retransmit the frame 1, not 2, 3, 4. Here, there is a new concept called negative acknowledgement. What is the meaning of negative acknowledgement? Previously, only the role of checking was for the sender side. Here, receiver will also play an important role. How receiver will do this negative acknowledgement concept? Listen this. If I am saying, yes, in previous class, today we will discuss this. So, there is a change, means in previous class and pause, today we will discuss this, means you can understand there is something which is missing. Might be I was trying to say in previous class what we have covered, today we will continue with this. So, here this particular line was missing. Now, any student can ask, yes sir, might be your voice was distorted and we are unable to get that particular complete line. So, this type of negative acknowledgement, you can say yes, frame 1, 3 and 4 are received, but negative acknowledgement for frame 2, that I have not received the frame 2. What you have said? Take an example, take 4 variables A, B, D and do this task. Now, you will say only 3 variables you have said, sir, what about the 4th variable? C is missing. So, this is some sort of negative acknowledgement, and for the frame which sender is receiving the negative acknowledgement, only those frames will be retransmitted, not whole. So, it will save your bandwidth, it will save the channel capacity. What is the diagram for this? Let us have a look to this. Here it is mentioned that out of this window, the window is there, but in the window how many negative acknowledgements are there which is received by the sender end from the receiver end side. So, here these red are the received ones, but yet we have not received the acknowledgement of 3. What it means? Means we need to send the 3 again, not 4, 5, 6, 7 all, because 4 is received. Okay? See one diagram for this. So, this is what I have explained about the negative acknowledgement. Negative acknowledgement says it shows the packet is not yet received or need to transmit again, need to retransmit. So, some of the times I have used the terminology packet, basically we are talking about the frames at data link layer. So, just ignore this part. This is one example activity diagram or sequence diagram about the selective repeat. Here you can see this frame 0, it is acknowledged, then frame 1 was lost, frame 2, 3. So, receiver will send the negative acknowledgement about this one, that I have not received the packet 1, means after 0 I have received directly 2. This is what he has received, the red one or the highlighted one. Similarly, 3 is received, but I am waiting for 1, 1 is not yet received. So, negative acknowledgement for 1. When there is a negative acknowledgement of 1, what sender will do? Frame 1 will be retransmitted. So, this is the retransmission 1. So, what is the advantage of this? We have saved the retransmission of 2 and 3. Okay? So, this is the advantage of using selective repeat. Now, if I sum up, what are the advantages and disadvantages I have discussed about. If I sum up the lecture, what we have discussed so far, we have started the work with the transmission, either it is under the noiseless channel or noisy channel, simplest stop and wait. Then we are talking about the noisy channel where we are demanding for the acknowledgement. If there is some sort of error in the frames, we are talking about the error control. How we are controlling the error? With the automated replies, automated request and responses. For this we have 3 methods: stop and wait, ARR. Then we have the another one where we are talking about the window size. So, what should be the window size? It depends on the algorithm, means which type of programming you are doing, what how many number of frames you want to accommodate in the window. So, the again this is a open ended question, what should be the size of window when you are using it. So, generally it gives in the question, or we are assuming it is 5, 6 or 7, 7 frames can be accommodated at a single place. Yes, there is another one in this, there was in go back n number of packets are sending again, then selective repeat. There is one important question in the gate. Yes, if we are saying in my go back n, this value of n is 1, if the window size is 1, how your system behaves like? So, it will behave like normal stop and wait method, because now the window size is 1, I am sending 1 frame expecting the acknowledgement. What it is? It is stop and wait. So, this is very important question, that is why it is highlighted in red. So, again there is an open ended question, as all the lectures you have seen, there is in the end you have seen one open ended question. If you are making your own network, which type of scheme you will prefer, stop and wait, go back n or selective repeat. So, this is all about the today's class. In next class we will talk about the framing method. Thank you.